All right, so today we're diving into something that's pretty crucial, especially if you're aiming for those senior software engineering roles.
Mm-hmm.
It's all about how we represent data efficiently in systems.
Yeah, this is the stuff that really trips people up, I think, when you get to system design rounds.
Oh, yeah.
Like, how do all these different services talk to each other?
Right.
How do we make that communication as, performant as possible?
Exactly.
But,
Yeah, and all the little nuances, all the edge cases.
Yeah.
You really got to have a good grasp of the fundamentals.
For sure.
So I guess the big question is, like, when you are designing these systems, right?
Yeah.
And you've got data flowing back and forth.
Right.
The format you choose
Huge impact. Yeah.
has a ripple effect,
Yeah,
right?
absolutely.
It affects speed. It affects how well different parts of the system can talk to each other.
Yep.
And even just the long-term maintainability of your architecture.
Totally.
So we're going to focus on binary encodings today, right?
Yeah, I think that's something that, a lot of folks should at least have in their tool belt.
Absolutely.
When they're thinking about these things.
So, okay, we all know those text-based formats like JSON, XML,
Sure.
CSV. They're human readable,
Right.
which is nice. But then there's this whole other world of schema-based binary encodings, right?
Exactly.
ProtocolBuffers,
Yeah.
Thrift, Avro. What makes them so attractive, especially when performance really matters?
Yeah, so I think the core difference really comes down to this idea of a schema.
Okay.
Right. So with these binary formats, you define the structure of your data up front, almost like a contract.
Right.
And, what's interesting is that their schema languages, while still being, expressive, tend to be simpler than something like XML schema or JSON schema.
Right.
Which, those can be really powerful, but also get quite complex.
Yeah, they can get pretty hairy.
Pretty hairy, exactly.
Yeah.
And so that kind of streamlined approach can actually make things a lot easier to manage,
Right.
especially as your system starts to evolve and grow over time.
Yeah, it's almost like you're setting up clearer rules of engagement from the start.
For sure.
Now, this idea of a schema, that's not entirely new, is it?
No, not at all.
I vaguely recall something called ASN.1.
Yeah, ASN.1. So if we zoom out a little bit historically,
Right.
ASN.1 is like an older standard for defining data structures.
Okay.
It goes all the way back to 1984.
Wow, okay.
And it's actually used in some pretty fundamental network technologies,
Okay.
like SSL certificates, for example.
Oh, interesting.
And, it does support SchemaEvolution in a way similar to ProtocolBuffers and Thrift.
Okay.
But its complexity and, the fact that it's not super well documented, it means it's probably not the first thing you'd reach for today if you were building a brand new distributed system.
Right. Makes sense. It's interesting how even within the specific systems, you can almost have like these highly optimized internal languages for data exchange, right?
Absolutely.
Yeah.
Like if you think about a lot of data systems, like relational databases, they actually use their own proprietary binary formats for communication internally over the network.
Interesting.
And so that's why you typically need those vendor-provided drivers, like ODBC or JDBC, to basically act as a translator between that internal format and something that your application can actually understand.
Okay, that makes sense. So we've kind of laid the groundwork. We've talked about what these schema-based binary encodings are.
Yeah.
Now, for someone who's prepping for those senior-level interviews, why should they care?
Right.
What are the key advantages that they should have in their mental toolkit?
Okay, so there are several really compelling reasons.
Yep.
First and foremost, compactness.
Okay.
So because both the sender and the receiver have the schema, you can actually omit the field names in the encoded data. And this can lead to some pretty significant reductions in data size.
Interesting.
We're talking potentially 30 to 50% smaller than JSON.
Wow. Okay.
In a lot of typical cases.
Yeah.
And that obviously has huge implications for performance, right?
Right.
It means faster transfer times, lower bandwidth consumption.
Yeah.
Which is especially critical in high throughput systems.
Absolutely. Yeah.
So, think about cloud costs, think about mobile app performance.
Oh, yeah.
These things can really add up.
Huge.
Yeah.
Smaller data means faster transfers, less resources being used.
Exactly.
What else? What's another big win?
Okay, so the second one is documentation.
Okay.
And this is kind of interesting because the schema itself actually serves as documentation for your data structure.
Right.
And because it's essential for decoding the data,
yeah,
you can be a lot more confident that it's actually accurate and up to date.
Right, so you don't have that problem where the documentation gets out of sync with what the code is actually doing.
It's like living documentation.
Yeah, that's a huge plus for long-term maintainability, reducing errors when you have different teams working together.
For sure.
It's all interconnected.
Yeah.
What's number 3?
Number 3, compatibility.
Okay.
And this is a big one, especially as systems evolve over time.
Right.
So by managing your schemas in like a central place, you can actually check whether changes you're making are going to be forward and backward compatible.
Right.
Before you even deploy them.
So you can catch those breaking changes.
Exactly.
Before they cause problems in production.
So backward compatibility means that your older systems can still understand data from the newer ones.
Gotcha.
Forward compatibility means the newer systems can handle data from the older ones, maybe by ignoring new fields they don't recognize.
Right, right.
And this is like super valuable in those microservices architectures.
Yeah, where everything's constantly evolving.
Exactly.
So that's a superpower. You're preventing deployment nightmares.
Hopefully, yeah.
That's awesome.
Fingers crossed.
And you mentioned something about code safety as well.
Yes, TypeSafety.
Okay.
This is the 4th one. It's particularly relevant if you're working with statically typed languages.
Okay.
So a lot of these systems actually let you generate code directly from the schema.
Okay.
Which means you get compile time type checking.
Right.
So you catch potential errors before they even make it to runtime.
So much better than trying to debug them.
Way better. Way better. It's like having that validation baked in.
Right, at the code level.
Right from the start.
Nice.
Yeah.
So it sounds like these binary formats almost give you that kind of flexibility that we associate with like schemaless databases.
Right.
Where you can evolve your data over time, but with much stronger guarantees about data integrity and consistency.
Yeah, you get the best of both worlds in a way.
Yeah, you get the agility, but with some built-in safeguards.
Exactly.
Awesome. Well, this has been a really insightful look into efficient data encoding. I think the key takeaway for anyone listening who's prepping for those senior tech interviews is that these schema-based binary encodings, they offer some serious advantages.
Definitely.
We talked about efficiency, documentation, compatibility, type safety.
Yep.
And understanding those trade-offs
absolutely
is really crucial for showing that you can think about system design
for sure
in a holistic way.
Yeah, you got to have the big picture.
So for all of you listening out there, as you're preparing for these discussions, think about those scenarios where the simplicity and the human readability of text-based formats might still be the better choice.
It's not always black and white.
Right. And conversely, in what kinds of systems, those high-performance distributed systems, are these binary formats going to be non-negotiable?
Yeah, where would you absolutely need that robustness and efficiency?
Exploring those nuances is really going to sharpen your skills.
Absolutely. It's all about making those informed trade-offs.
Awesome. Well, thanks for joining us on the deep dive today.
Yeah, thanks for having me.
And we'll catch you next time.
See you later.